Hello friends, you are watching channel number Collage. This is my sincere effort to help you understand basic mathematics in a simple and easy manner. In this video, we will understand collinear vectors, coplanar vectors, linear combination of vectors, and how we can use linear combination of vectors to show collinearity and coplanarity of vectors. Linear combination of vectors r bar equals m a bar plus n b bar, where m and n are scalars, is called linear combination of vectors a bar and b bar. Similarly, r bar equals x a bar plus y b bar plus z c bar, where x, y, z are scalars, is called linear combination of vectors a bar, b bar and c bar. Collinear vectors. Two vectors are said to be collinear if they lie on the same line or they are parallel to each other. If two vectors a bar and b bar are collinear or parallel, collinear because they lie on the same line, parallel because they are parallel to each other. A bar equals alpha b bar, where alpha is a scalar, or b bar equals beta a bar, where beta is a scalar. That is, if a bar is a scalar multiple of b bar, a bar is scalar multiple of b bar, or if b bar is a scalar multiple of a bar, b bar has a scalar multiple of a bar, then a bar and b bar are collinear like these vectors or parallel like these two vectors. In general, for two vectors a bar and b bar, if m a bar plus n b bar equals a zero vector, then m a bar will be minus n b bar, or a bar will be minus n by m times b bar, where m is a non-zero scalar. Here, a bar is a scalar multiple of b bar, which implies a bar and b bar are collinear vectors a bar and b bar. Similarly, if b bar equals minus m by n times a bar, where n is a non-zero scalar, here b bar is a scalar multiple of a bar, which implies a bar and b bar are collinear vectors or parallel vectors, like this. What are coplanar vectors? A set of vectors is coplanar if their corresponding position vectors lie in the same plane. A vector r bar is coplanar with a bar and b bar if there exist unique scalars m and n such that r bar equals m a bar plus n b bar. R bar equals m a bar plus n b bar means among three vectors, if any one vector can be expressed as a linear combination of the remaining two vectors, then the given three vectors are coplanar. This is what it means. Suppose a bar, b bar and r bar are coplanar vectors, and let a bar equals o a bar, b bar equals ob bar, and R bar equals OR bar. These are coplanar vectors. O is the origin. Suppose R bar is collinear with A bar. Then R bar will be M A bar, where M is a scalar, or R bar will be M A bar plus N B bar, where N is 0. Let R bar be non-collinear with A bar and B bar. You can see vectors A bar, B bar and R bar are non-collinear vectors. Take point Q on A bar here and take point S on B bar here. Complete the parallelogram. O, Q, R, S. Now OQ bar is collinear with A bar. Therefore we can write M A bar equals OQ bar. M A bar equals OQ bar. Similarly, OS bar is collinear with B bar. So we write NB bar equals OS bar. By parallelogram law, we write OR bar equals OQ bar plus OS bar. That is, R bar equals MA bar plus NB bar. In R bar equals MA bar plus NB bar, R bar is a linear combination of A bar and B bar. So we conclude that if R bar is coplanar with A bar and B bar, then we can write R bar as a linear combination of A bar and B bar like this. Conversely, if R bar equals MA bar plus NB bar, that is R bar as a linear combination of A bar and B bar, then vector R bar is in the plane of A bar and B bar. That is, R bar is coplanar with A bar and B bar. R bar is coplanar with A bar and B bar. For three coplanar vectors R bar, A bar and B bar, the linear combination R bar equals M A bar plus N B bar is unique. We will see why is it unique. Suppose this linear combination is not unique, then we will write another linear combination R bar equals P A bar plus Q B bar with different scalars P and Q, which implies that M A bar plus N B bar, which is this, equals P A bar plus Q B bar, which is this. We write M A bar plus N B bar minus P A bar plus Q B bar equals a zero vector, which will be M minus P times A bar plus N minus Q times B bar equals a zero vector, which implies that M minus P equals 0 and N minus Q is also equals 0. Therefore, M will be equal to P from this and N will be equal to Q from this, which proves that the scalars M and N are unique. Therefore, R bar equals M A bar plus N B bar is a unique linear combination for three vectors R bar, A bar and B bar. Three vectors A bar, B bar and C bar are coplanar only if there exists a non-zero linear combination x A bar plus y B bar plus z C bar equals a zero vector. We will prove this. For that, let A bar, B bar, C bar be coplanar vectors. Then in this case, we will assume A bar and B bar to be collinear. So we write x A bar plus y B bar equals a zero vector, or x A bar plus y B bar plus z C bar equals a zero vector where z equals 0, which is the required non-zero linear combination. In case 2, we assume none of the two vectors A bar, B bar and C bar are collinear. But we know that C bar is coplanar with A bar and B bar. So we write C bar equals x A bar plus y B bar. That is x A bar plus y B bar plus z C bar equals a zero vector where z is -1. Conversely, suppose x A bar plus y B bar plus z C bar equals a zero vector where one of x, y, z is a non-zero scalar. Say z is non-zero. Then we write C bar equals x by z A bar plus y by z B bar. So therefore C bar is coplanar with A bar and B bar, which implies A bar, B bar and C bar are coplanar vectors. If A bar, B bar and C bar are three non-zero non-coplanar vectors like these, then any vector R bar in space, this one, can be uniquely expressed as a linear combination of the vectors A bar, B bar and C bar as R bar equals x A bar plus y B bar plus z C bar, x A bar plus y B bar plus z C bar, which is this vector R bar. Let O be the origin, this one, and A bar, B bar, C bar and R bar be the position vectors of the points A, B, C and R. OR equals R bar, OA equals A bar, OB equals B bar, OC equals C bar. Now A bar, B bar and C bar are non-coplanar vectors. We will draw planes parallel to the planes BOC, COA and AOB. Plane parallel to BOC is this one. Plane parallel to COA is this one, and plane parallel to AOB is this one. These planes intersect OA, OB and OC in points L, M, this one, and N, this one. From the figure, OA bar is collinear with OL bar. OA bar, which is A bar, is collinear with OL bar. Therefore, OL bar will be X A bar, where X is a scalar. Similarly, OM bar will be YB bar. OM bar will be YB bar, and ON bar will be ZC bar, where Y and Z are scalars. In triangle OLS, by triangle law, we have OS bar equals OL bar plus LS bar. So OS bar will be XA bar plus YB bar, because LS bar is same as OM bar and it will be YB bar. So we get OS bar equals XA bar plus YB bar. Now in triangle OSR, by triangle law, we write OR bar equals OS bar plus SR bar. OR bar equals OS bar plus SR bar. That is, R bar equals XA bar plus YB bar plus ZC bar, which implies that any vector R bar in space can be uniquely expressed as a linear combination of vectors A bar, B bar, C bar. We have to show that the points A 1 minus 2 3, B 2 3 minus 4 and C 0 minus 7 10 are collinear points. First we will write A bar, which is the position vector of point A, as I cap minus 2j cap plus 3k cap, and B bar, which is position vector of point B, as 2i cap plus 3j cap minus 4k cap, and C bar, the position vector of point C, as minus 7j cap plus 10k cap. Next we will find out AB bar, which will be B bar minus A bar. We will substitute the values of B bar here and A bar here. In the next step we will open the bracket here and change the signs, so that AB bar will be 2 minus 1, that is I cap, plus 3 plus 2, that is 5j cap, minus 4 minus 3, that is minus 7k cap. Next we will find AC bar, which will be C bar minus A bar. We will put the values of C bar here and A bar here. We will open the bracket here and change the signs, so that we will get AC bar as minus I cap, minus 7 plus 2, that is 5j cap, and 10 minus 3, that is 7k cap. We will take minus 1 common from here and write minus times I plus 5j plus 7k, but I plus 5j cap plus 7k cap is nothing but AB bar here. So we write AC bar equals minus 1 times AB bar. Here we observe that vector AC bar is a scalar multiple of AB bar. This is the scalar, which implies that AC bar and AB bar are collinear vectors, but they have A as the common point, which proves that points A, B and C are collinear points. If the vectors 3i minus 5j plus k and 9i minus 15j plus pk are collinear, then we have to find the value of q, which is this. We will name the vectors as a bar equals 3i minus 5j plus k and b bar equals 9i minus 15j plus pk. Now, since it's been given a bar and b bar as collinear vectors, so we write b bar equals t, which is a scalar, times a bar. We will open this bracket and write 3t minus 5t and t. Next, we will compare the coefficients of I, j and k and write here. So 3t equals 9 gives us t equals 3. Now we will compare the coefficients of k cap. So it gives us p equals t. So p equals t, which is 3. Therefore p equals 3 is the answer. In this question, we have to show that the vectors 4i plus 13j minus 18k, I minus 2j plus 3k and 2i plus 3j minus 4k are coplanar. First, we will name these three vectors. We will call the first vector as a bar, the second vector as b bar, and the third vector as c bar. Since we have to show that these three vectors are coplanar, we have to check whether we can express any one of these vectors as a linear combination of the remaining two. So let us first express a bar as a linear combination of b bar and c bar. So we will write a bar equals m b bar plus n c bar, where m and n are non-zero scalars. So we will write the values of the vectors. This is a bar m times b bar plus n times c bar. After that, we will write m plus 2n times I plus minus 2m plus 3n j and plus 3m minus 4n times k. Now we will compare the coefficients of I, j and k and write m plus 2n equals 4, minus 2m plus 3n equals 13, and 3m minus 4n equals minus 18. So these are linear equations in variable m and n. We can find the values of m and n from any two of these three equations, and those values of m and n we will substitute in the third equation and check if those values of m and n are satisfied by the third equation. For finding the values of m and n, we will solve any two of these three equations. The values that we got, we will substitute in the remaining equation and see if that remaining equation is satisfied by these values. Let us solve these three linear equations. First, we will multiply the first equation by 2. So it becomes 2m plus 4n equals 8. Now we will write this third equation below this equation. Here 4n minus 4n becomes 0 and 3 plus 2 becomes 5m equals minus 18 plus 8, that is minus 10. So that gives us m equals minus 2. We will substitute this value of m in the first equation and write minus 2 in place of m plus 2n equals 4. So that will be 2n equals 6 and n equals 3. So we got m equals minus 2 and n equals 3. We can substitute these values in the remaining equation, which is this one, and see that this equation is satisfied by the values of m and n. So that we can write a bar as a linear combination of b bar and c bar, where m is minus 2 and n is 3, which are non-zero scalars. Therefore, since we are able to write a bar as a linear combination of b bar and c bar, we can say that vectors a bar, b bar and c bar are coplanar. If a bar, b bar and c bar are non-coplanar vectors, then we have to prove that the vectors a bar minus b bar plus c bar, a bar plus b bar minus 3c bar, and a bar plus 4b bar minus 9c bar are collinear. First, we will assume P, Q and R as the points whose position vectors are P bar equals a bar minus b bar plus c bar, which is this vector, Q bar equals a bar plus b bar minus 3c bar, which is this second vector, and R bar equals a bar plus 4b bar minus 9c bar, which is the third vector. Now we will find out PQ bar, which will be Q bar minus P bar. We will put the values of Q bar and P bar. We will get a bar minus a bar will be 0, b bar plus b bar will be 2b bar, minus 3c bar minus c bar will be minus 4c bar. Next, we will take 2 as the common factor and write PQ bar equals 2 times b bar minus 2c bar. Next, we will find out PR bar, which will be R bar minus P bar. We will write R bar here minus this is P bar. A bar minus A bar will be 0. 4B bar plus B bar will be 5B bar, and minus 9C bar minus C bar will be minus 10C bar. We will take 5 as the common factor and write PR equals 5 times B bar minus 2C bar. Now we have PQ bar and PR bar. We will take ratio of PQ bar and PR bar, which will be 2 times B bar minus 2C bar upon 5 times B bar minus 2C bar. B bar minus 2C bar gets cancelled and we are left with 2 by 5, which gives us PQ bar equals 2 by 5 PR bar. Since PQ bar is a scalar multiple of PR bar, it implies that PQ bar and PR bar are collinear vectors. That is, points P, Q and R lie on the same line. Therefore, given vectors are collinear is proved. Show that the points A 451, B 534, C 416 and D 333 are coplanar points. From the given points, we will write the position vectors of these points and assume that A bar, B bar, C bar and D bar be the position vectors of these 4 points. So that we write A bar equals 4i plus 5j plus k, B bar equals 5i plus 3j plus 4k, C bar equals 4i plus j plus 6k, and D bar equals 3i plus 3j plus 3k. Next, we will find AB bar, which will be B bar minus A bar. We will substitute B bar here and A bar here. It will be 5 minus 4, that is I, 3 minus 5, that is minus 2j, and 4 minus 1, that is 3k. AC bar will be C bar minus A bar. C bar is this one and A bar is this vector. So we get 4 minus 4, that is 0i, which we haven't written here. Then 1 minus 5 will be minus 4j, and 6 minus of minus, that is plus 1. 6 minus 1 will be 5k. So AC bar is minus 4j plus 5k. Then AD bar is D bar minus A bar. D bar is this vector and A bar is this vector. And we get AD bar as 3 minus 4, that is minus I, 3 minus 5, that is minus 2j, and 3 minus 1, that is 2k. So AD bar is minus I minus 2j plus 2k. We will show vectors AB bar, AC bar and AD bar to be coplanar. For that, we will write AB bar as a linear combination of AC bar and AD bar, where T1 and T2 are two scalars. We will substitute AB bar, AC bar and AD bar. We will open the brackets here and we will have minus T2 I cap plus minus 4T1 and minus 2T2 J cap plus 5T1 plus 2T2 K cap. Now we will equate the coefficients of I cap, J cap and K cap and write minus T2 equals 1 gives us T2 equals minus 1. Substituting the value of T2, we get minus 4T1 minus 2 times minus 1, which is this, equals minus 2. So that gives us minus 4T1 equals minus 4 and T1 equals 1. By using the values of T1 and T2, we write AB bar equals AC bar minus AD bar. So since AB bar is a linear combination of AC bar and AD bar, we conclude that A, B, C, D points are coplanar. In the next video, that is Vector Basics Part 7, we will talk about the section formula. Hope you liked this video. If you did, please click the like button. Do subscribe this channel. Share this video with your friends and relatives. Thanks for watching. Keep watching Number Collage. Thank you.